What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Games. As we continue to explore the QF.2 notes dealing with quadratic functions and graphs. So up to this point, we have taken a look at key features of graphs. We've figured out how to find the x-intercepts and y-intercepts algebraically. We've looked at graphing equations in vertex form and rewriting standard form into vertex form using the method of completing the square. Today we're going to try to create a shortcut for rewriting equations in vertex form, or even not so much rewriting the equation in vertex form, but finding the vertex so that we can use transformations in order to graph. So let's go ahead and let's jump down. This should be the bottom of page 4. If you're following along in the notes, if you're taking it on notebook paper, that's fine as well. So we're going to graph quadratic functions using what we call the vertex formula. So let's say for any quadratic function, let's make it f of x, we know the standard form, equal to ax squared plus bx plus c. And let's say this is with vertex, and let's use kind of what we normally use, hk. So if we have a quadratic function and it has the vertex hk as we normally label it. If this is the case, h can be found by using an equation. So h is going to be equal to negative b over 2a. So this is kind of like a portion of the quadratic formula. It's just the negative b part over the 2a part. There's no addition of the discriminant in there. So we can find the x value of the vertex by taking negative b over 2a. To find the y value of the vertex, you find f of h, meaning once we figure out what h is, the x value is, we can put it into the equation and then solve for y. So let me give you an example there. Let's say that f of x is negative, let's say it's, oops, let's use the same problem we saw today in our warm-up. Let's say it's negative x squared plus 4x plus 5. Now, we did this problem in our Zoom discussion today where we found the vertex by completing the square. If I want to use the vertex formula, what I would do here is I would take a little substitution into h. So a negative b would be negative 4 over 2a. And my 2a, so my 2 is just going to stay 2, times a would be negative 1. So if I want to simplify this, negative 4 over negative 2 would be positive 2. So that's my x value for my vertex. If I want to find k, my y value of my vertex, I'm going to take 2 and I'm going to substitute that into the equation. So I'll just do that over here on my calculator. I believe you guys can see that on the screen. So I would just take a 2 and substitute it in for x. And then I would get 9. So my x value for my vertex would be 2. And my y value for my vertex would be 9. So we can see that this method is a little bit easier, actually probably considerably amount easier than completing the square. So if you can remember this equation, it's not going to be given to you, but if you can remember this equation, in some instances, you're going to be allowed to use the vertex formula. And so we can substitute into this equation to find h, then take that value for h, substitute that into the function to find k, and now we have the vertex. So let's go ahead and take a look at some example problems. So in problem 5, it says, given each of the following, graph the quadratic function using the vertex formula. So they give me in 5a, g of x is 2x squared plus 8x plus 3. So I need to find my x and y coordinates. So h, again, is equal to negative b over 2a. So if I want to substitute into that, my b value here for g of x is 8. So I would have a negative 8 over 2 times my a value, which in this case is 2. So negative 8 over 2 times 2, or negative 8 over 4, would be negative 2. So my x coordinate for my vertex is going to be negative 2. To find k, I would take this negative 2 and I would substitute it into the equation. So I'm finding g of negative 2, which I will do on my calculator again. So 2 times the quantity negative 2 squared plus 8 times negative 2 plus 3. And then I can check my vertex should be, or my y value for my vertex should be negative 5. So my vertex is hk. So then my vertex in this instance would be 2, negative 5. And now we're ready to graph. So unless the question requires the finding of the x-intercepts and the y-intercepts, you can find the y-intercept here pretty easily. But unless the equation requires you to find that algebraically, we're not going to worry about doing that. So here we're ready to graph. So the first thing that I want to graph is my vertex. So negative 2, negative 5. And again, I'm going to show you how to do this using transformations. You're going to have your graphing calculator there to assist you. So we'll come back and take a look at the graphing calculator in a second. So I'm graphing my vertex to start with. I know that this parabola opens up because if we look at the leading coefficient, there is no reflection. So I'm going to need a vertical axis of symmetry going up from that vertex point. So there's my axis of symmetry. Remember that for a quadratic equation, horizontal movement is squared to create vertical movement. So if I go back to my vertex, I'm going to move right 1. I'm going to square that, and generally I'd move up 1. But notice I have a leading coefficient of 2. This leading coefficient, again, is my dilation factor. It'd be the same. That 2 would still be there if we completed the square. It'd be in front of the parentheses. So I'm doubling all my vertical distance. So I move to the right 1, square that number, and then double it. I move up 2. Go back to the vertex. I'd move to the right 2, 1, 2. Square that number, which would be 4. But now I'm going to double that number. So instead of moving up 4, I'm going to move up 8. That would end up being my y-intercept. Then I'm going to go back to the vertex, move right 3, 1, 2, 3. I would square 3 and move up 9 generally, but again, vertical dilation, I'm going to double that. I'd move up 18, which would take me off the graph somewhere up around here. If you want to graph that, you can, you don't have to. Then I'd go ahead and reflect those points over the axis of symmetry. And now I'm ready to sketch in my curve. So we have a general sketch there of the parabola. Again, it should be a little bit more U-shaped than it is V-shaped. This one's not so bad. Again, you'll have your graphing calculator there to help you. So if we want to check this, I'm going to go back to the very beginning. And I'm going to type in the initial equation that they gave me for g of x. And then I'm going to take a look at the graph. I'm just going to hit the graph key. This looks pretty similar to what we have here. Then I'm going to go ahead and take a look at the table by hitting second in graph, and then look at some of the table points. So I have this point negative 2, negative 5 on my graph. I have this point negative 1, 3 on my graph. I have this point negative, or sorry, here's negative 2, negative 5. Here's the point negative 1, 3. Here's the point 0, 3. I have negative 3, negative 3. And I have negative 4, 3. Any other points would be off my graph. So this is definitely sufficient for a graph here. So we can see the vertex formula here is a much quicker and easier way to find the vertex and then set us up in a method of graph. Go ahead and see if you can pause the video and complete 5B. Hopefully you've had a chance to look at 5B. So in graphing here, we're graphing h of x, which is 1/2 x squared plus 3x minus 5. So if I want to find my x coordinate of my vertex, I'm going to use the negative b over 2a formula. So in this case, my b is 3. So I'm going to have negative 3 over 2 times my a, in this case, is 1/2. So negative 3 over 2 times 1/2. If you type this in the calculator, make sure that you put 2 times 1/2 in parentheses or write it out as a fraction, as we see here on the screen. So if I have negative 3 over 2 times 1/2, that's essentially the same as negative 3 over 2 times, or sorry, negative 3 over 1, which would give us negative 3. Now, if I want to find my y-coordinate, for my vertex, I would find h of negative 3, or take negative 3 and substitute that into the equation. So again, I can do this in the calculator, 1/2 times negative 3 quantity squared plus 3 times negative 3 minus 5 graph, and there I have my my y value, which would be negative 9.5, or if you wrote this as negative 19 over 2, that would also be good. So my graph here then would be negative 3, comma, or my vertex would be negative 3, negative 9.5. Now let's go ahead and graph this. So I'm going to find negative 3, negative 9.5. I'm just going to go in between negative 9 and negative 10. It doesn't have to be perfect, but just as long as we're in between negative 9 and negative 10. There we go. There's my point. Then from here, we're going to graph the other points on this parabola. Again, I'm going to show you how to do this using transformations. So we know that this is a positive parabola. It's going to have an axis of symmetry that's going to open upward. So there I have one. It's going to be symmetric on both sides of this dashed line. I'm going to plot some points. I'm going to plot some points to the right of the axis here. So if I move to the right 1, generally I square 1 and go up 1, but I have a vertical dilation of 1/2, so I'm going to cut that distance in half. So if I move right 1, I'm actually going to move up 1/2, and there's my next point. If I go back to the vertex and I move right 2, generally I square that and move up 4, but again, we're cutting that vertical distance in half. I'm going to only move up 2, 1, 2. So this point would be at negative 1, negative 7.5, in between negative 7 and negative 8. If I move right 3, 1, 2, 3, I would square that value and generally move up 9. But again, we're cutting that distance in half because we have a vertical dilation of 1/2. So I would move up 4.5 units. I could keep doing this pattern. If I moved to the right 4 units, 1, 2, 3, 4, I would square that distance and move up 16 in general. But again, I'm going to cut that distance and move up 8. So I would be at 1, negative 1.5. So we got to make sure if we're graphing using transformations that we account for the changes to the vertical distance by this dilation factor. And I have more than enough points here to go ahead and sketch in a curve. So I'm going to reflect those across my axis of symmetry here. And then I'm going to sketch my curve. And there we have it. Looks like I'm getting a little bit better drawing with the mouse as we go along here as well. So it didn't have to be perfect, but again, we want that parabola to look a little bit more like a U than a V shape. I went ahead and I typed the values for the parabola, or the equation for the parabola, into my table, and I can check these values with what I have here on the graph. And so I can see I have 1, negative 1.5, I have 0, negative 5, I have negative 1, negative 7.5, I have negative 2, negative 9, I have negative 3, negative 9.5, and I could go to the left and see that I've graphed this one appropriately. And so there we have a sketch for our parabola. Okay, so this is an alternate method we can use as opposed to completing the square to rewriting equations unless we're required to complete the square. If you know the vertex formula, it's a much quicker method to find that vertex and allow you to set up a graph. Now let's move on. The real reason that we want to be able to graph and understand graphs of quadratic functions is that we want to be able to use quadratic functions in applications. So In the previous problems, I've shown you some algebraic methods for finding values for y-intercepts, for finding the x-intercepts, for rewriting the equation into vertex form, for graphing using transformations, for finding the vertex using the vertex formula. We went through algebraic methods. If we have a graphing calculator, a lot of these things become quite a lot more simple. And so what we're going to focus on in application problems, and I'm going to allow you guys to do this when you take your quizzes and your tests, because we're going to focus on using these graphing calculators. We have the skills to sketch a graph if we need to. You're going to see some problems where you have to do the algebraic work, sketch some graphs, but we're also going to need the skills to use our graphing calculator, which applies a lot better outside of the classroom, because I'm not going to graph anything by hand if I'm not in, and I'm going to use my graphing technology if I don't have to graph for a test. So we're going to work on using this technology here in the application problem. So let's take a look at problem number 6. It says an airplane manufacturer can produce up to 15 planes per month. The profit made from the sale of these planes is modeled by P of X, and it gives us a function where P of X is the profit in hundreds of thousands of dollars per month, and X is the number of planes sold. The first thing it says is to find the y-intercept and explain what it means in this context. So finding the y-intercept should be a pretty quick and decently easy concept for us. We know that the y-intercept is found by substituting in 0 for x, which algebraically is a fairly simple procedure for us, but even easier when we're given it the equation in standard form, because we know that it's just going to be the constant. So what we get is that, and I'm going to write it in this form, P of 0 equals -3. The reason that I write it in this form is because this allows me to have an easier transition into applying context to what this value means. We know that the y-intercept is -3, but if we don't know what that means, it doesn't serve us any purpose. So it says, explain what it means in this context. Well, P of 0, let's start there. P of 0 means my x value is going to be 0. Well, what is my x? X is the number of planes that are sold. So this is giving me essentially a point on my graph, 0, -3, and it's not this graph here. I'll shut this calculator off because that's not what we're looking at. It's 0, -3 on my graph. So when the x value, or the number of planes sold, is 0, -3 is the y value, which is, again, P of x. So P of x is the profit in hundreds of thousands of dollars. So what we have here is when 0 planes are sold, the manufacturer is going to lose $300,000. So remember, it says P of x is in hundreds of thousands of dollars. So this -3 is -$300,000, meaning that their profit is -$300,000, meaning again that they're losing $300,000. So though we can find the y-intercept pretty quickly, understanding what it means is by far the most important part of that. Now in part B, it says how many planes should be made and sold to maximize profit, and then it asks us what is the maximum profit in part C. In order to do part B and part C, we're going to actually need to take a look at the graph. So what I'm going to do is I'm going to go over here to my graphing calculator, and I'm going to type in the function that we see. So this function is -0.2 x squared plus 4x minus 3. And now I'm going to set my window. Now the x minimum and x maximum is what I'm going to adjust. So x minimum, x would be, again, the number of planes sold. We're not going to sell negative planes, so I'm going to go to 0. I'm going to go to 0. It says an airplane manufacturer can produce up to 15 planes per month. So I'm going to assume they can sell 15 per month, and that's going to be my x max. So we want to use the equation or the scenario, the problem that we're given, to set up our window by adjusting the x minimum and x maximum. Now what I can do with this is I can hit the zoom key and go down to zoom 0, which is zoom fit. What this is going to do is it's going to draw or sketch a graph for me based on my X values that I set up. So here's our graph. So if we're going to do this graphically, our graph is our work. So we're going to go ahead and we're going to sketch a graph. So what I did here was I sketched out basically an example of what we see in the graphing window. Now again, it doesn't have to be perfect. We want to make it look as close to the window as we can. I did the best I can drawing with a mouse here. So this is our graph, and this is essentially going to be our work. Now we don't just want a graph. We want to make sure that we label axes and give context to this graph so that a reader of the graph can understand what's going on. So the x-axis goes back to the x value. What is x? Well, x is the number of planes sold. So let's go ahead and let's label that axis. And so I went ahead and labeled the x-axis as number of planes sold. In addition, I also included some values on my x-axis, knowing that we start here at 0 on the y-intercept, or sorry, the y-intercept here, this value is 0 on the x, and that we're ending at 15 on the x. So it kind of gives our graph a little bit of a numeric representation as well. We also need to make sure that we label the y-axis. So the y-axis is P of x, or profit in hundreds of thousands. So there I have a label for my y-axis. Now, let's go back to the question. I've got a graph. I'm going to use this graph to solve. I sketched that graph. This graph is going to essentially take place of my work. So the question was, how many planes should be made and sold to maximize profit? Well, let's look at our graph. Now that we have it labeled, the y-axis here shows us profit. So what we want is we want the highest value possible on the y-axis. So if I follow my graph along, it curves, comes to the top, and then at one point it starts to turn around and come back down. Mine's not the greatest, but let's just say it's right here. This is the vertex point. So the vertex point is where it's turning and now it's coming back down. So this is profit is increasing as I follow this graph. Profit is increasing, 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 and now it starts to decrease. So we already talked about increasing, decreasing intervals. What we want is the relative maximum point. We want the highest value for the y in that general location. So if we look here, the relative maximum is going to be right there. Now, this is the vertex. So if you want to find the vertex algebraically, that is absolutely okay. You can use the formula h equals negative b over 2a to find the x value, and then you can substitute that x value into the equation to find the y value. What I'm going to allow you to do for application problems is use your graphing calculator. So the graphing calculator is going to do this work for us. So if I hit second and I hit trace, that's going to take me to the calculate menu. What I can find here is a bunch of different options, and all of these find different things on the graph. What we're looking for is maximum. We're looking for a relative maximum. So we're going to go down and select 4. It's going to say left bound and give me a question mark. What you can see on my screen is as I push the arrows left to right, it's changing this little cursor. What I want is my cursor to be on the left of my relative maximum. So I know my relative maximum is somewhere in here. I'm going to make sure my cursor is on the left and then hit enter. Now it says right bound. So I'm going to go ahead and move my cursor to make sure it's on the right of that relative maximum. I don't know exactly where that maximum is at. I just want to make sure my cursor is on the right and hit enter. And now it's going to ask me to guess. You can guess if you want to. You don't necessarily need to guess. I'm going to move my cursor in there somewhere. That looks about like the peak point right there. And I'm going to hit enter and let the calculator work. So what the calculator does sometimes is, depending on how close you set your bounds, it's going to round things just a little bit. So we're going to see that right here. It did kind of round my answer just slightly, but we can go ahead and figure out that this x value should be 10. So my point here is going to be my solution. So what I'm going to do is I'm going to come to the graph and I'm going to make this point. Let's call this point, let's just say again that this point is my relative maximum. That's a really big point, but you're going to get the idea. And then I'm going to label this point, and this is my work. So there I have a label for the point. And again, this is essentially taking place in my algebraic work. So what this point allows me to do is go back to my axes and then answer the question that they're asking for. It says, how many planes should be made and sold to maximize profit? Well, here's my point that's going to maximize profit. Number of planes is the x. So x represents the number of planes again sold. I need to make and sell 10 planes per month. So I want to make sure I go ahead and back in and put context into this. So I want to make and sell 10 planes per month. If you just said 10 planes per month, that would be okay. Question C says, what is the maximum profit? Well, again, profit is the Y coordinate here. So I'm going to go to my graph. The Y coordinate is 17. Now remember, 17 is in hundreds of thousands of dollars. So actually what I have here is $1,700,000, or a maximum profit is $1.7 million. If you wrote that all out, that's okay. If you wrote $1,700,000, that would be okay. Or $1.7 million per month is the maximum profit. So what we're doing here is we're using the graph of the function in order to find some contextual information about that function and then interpret that information. So we know that here for this manufacturer, if they brought us some questions here, we could tell them that, hey, if you don't sell any planes, every month you're gonna lose $300,000. If you want to maximize your profit, you need to manufacture and sell 10 planes per month. And if you do that, you're going to make $1.7 million each month. So we can use graphs of functions to create context for solutions. Again, you can do each of these questions algebraically. That's going to be an option that you have to you. But when it comes time for assessment, if you have the graphing calculator, we're going to use the graphing calculator as an option as well and have that work shown as your graph. Okay. I'm a little short on time here. This is going to be where I'm going to go ahead and end the video. For now, problems 7 and 8 I will post later today. Okay. So again, as always, thank you guys for tuning in, and I will see you soon.